ನಮಸ್ಕಾರ, ಗುಡ್ ಮಾರ್ನಿಂಗ್.
ಗುಡ್ ಮಾರ್ನಿಂಗ್, ನಮಸ್ಕಾರ ಸರ್. ವೆಲ್ಕಮ್
ಸರ್. ಹೇಗಿದ್ದೀರಾ?
ಹೇಗಿದ್ದೀರಿ ಸರ್?
ಐ ಆಮ್ ಡೂಯಿಂಗ್ ಫೈನ್, ಥ್ಯಾಂಕ್ ಯು.
ಅಲ್ಲಿ ಲೋ ಡಿಪ್ರೆಷನ್ ಇದೆ, ಲೋ ಪ್ರೆಷರ್, ಸೊ ಇಟ್ ಇಸ್ ರೈನಿಂಗ್ ವೆರಿ ಹೆವಿಲಿ.
ಓ, ರೈನಿಂಗ್. ಓಕೆ. ಬೆಂಗಳೂರು ಎಲ್ಲ ಮಳೆ ನಿನ್ನೆ.
Last year also we faced flood.
ಶೇರ್ ಸ್ಕ್ರೀನ್ ಒಂದ್ಸರಿ ಚೆಕ್ ಮಾಡ್ಬಿಡ್ತೀನಿ.
ಶೇರ್ ಸ್ಕ್ರೀನ್ ಎನೇಬಲ್ ಮಾಡಿರಿ.
ಶೇರ್ ಸ್ಕ್ರೀನ್ ಒಂದ್ಸರಿ ಎನೇಬಲ್
ಕ್ಯಾಮೆರಾ ಕ್ವಾಲಿಟಿ ಸ್ಮೂತ್ ಆಗಿದೆ.
ರಶ್ಮಿ. ಆಫೀಸಿಂದ ಏನಾಯ್ತಾ?
ಫೋಟೋ ಎಲ್ಲ ಡೌನ್ಲೋಡ್.
ಸರಿ, ಹೇಳ್ತೀನಿ. ಕರ್ಕೊಂಡು ಹೋಗ್ತೀರಾ ಈಗ?
Good morning, Vice Chancellor Sabre.
Good morning, good morning. How are you?
Yeah, I'm fine, doing fine. How about you?
I'm fine.
Okay. Okay. Where is the depression? It is in Shivamogga or Bangalore?
Depression is there in the Bay of Bengal, but the effect is there in Shivamogga, Chikmagalur, Bangalore, Hassan.
Okay, okay. Good. Veeranna is there and two more people I could not recognize because of their masks.
Good morning, sir. Good morning, sir.
Good morning, sir. Mohan Kumar.
Shashidhar.
Oh, Mohan Kumar, sir. Okay, Shashidhar. Okay, good.
Dinesh, your classmate.
Dinesh is well suited. That's why. So well dressed.
Dress to the occasion.
Yeah.
Thank you.
Yeah, he is a flag bearer of the university. No? He should be well dressed.
Okay.
Sir, morning from Panampet, sir.
Yeah. Auditorium, I think you can light it. Okay. Why lighting is less in auditoriums?
On the generator.
Yeah.
On the generator. Auditorium lighting ಕಡಿಮೆ ಇದೆ ಅಂದ್ರೆ.
ಎಲ್ಲಿ auditorium? ಅಲ್ಲಿಯಾ?
Panampet, sir.
ಈಗ ಎಲ್ಲ ಬೇರೆ ಬೇರೆ ಕ್ಯಾಂಪಸ್ನವರು ಅವರು ಅಲ್ಲೆಲ್ಲ ಇದು ಮಾಡ್ತಾ ಇದ್ದಾರೆ.
ಕರೆಕ್ಟ್. ಅದೇನ್ ಮಾಡ್ತಾ ವಿಂಡೋ ಸ್ಕ್ರೀನ್ಸ್ ಹಾಕಿದ್ರೆ ಅಂಡ್ ಇಂಡೋರ್ ಲೈಟಿಂಗ್ ಆದ್ಮೇಲೆ ದೇ ಆಲ್ ವಿಲ್ ಬಿ ವಿಸಿಬಲ್. ಸ್ಟೂಡೆಂಟ್ ಶುಡ್ ಬಿ ವಿಸಿಬಲ್ ಅಲ್ವಾ?
ಅದನ್ನ ಹಾಕ್ಬೇಕಾ? ಅಲ್ಲ ಪವರ್ ಇಲ್ಲ, ಅದನ್ನೇ ಮಾಡ್ತಿದ್ದೀನಿ.
ಜನರೇಟರ್ ಆನ್ ಮಾಡಿಲ್ವಾ?
ಹಲೋ, ಆ ಶೇರ್ ಸ್ಕ್ರೀನ್ ಒಂದ್ಸರಿ ಚೆಕ್ ಮಾಡ್ತೀನಿ. ಎನೇಬಲ್ ಮಾಡ್ತೀರಾ?
ಮಾಡಿದೆ.
Enable ಇದೆ ಸರ್.
ಮತ್ತೆ ಡಿಸೇಬಲ್ಡ್ ಅಂತ ಬರ್ತಾ ಇದೆ.
ಓಕೆ
Enable ಇದೆ.
ಹಾ ಓಕೆ, ಈಗ ಆಗಿದೆ.
Okay.
ಬಾಟಮ್ ಆಫ್ ದ ಸ್ಕ್ರೀನ್ ಇರುತ್ತೆ ನೋಡಿ.
ಅದೇ ಗೊತ್ತಾಯ್ತು.
ಹಾಗೆ. ಹಾ ಬಂತು.
ಬರ್ತಿದ್ಯಾ?
ಎಸ್ ಸರ್, ಎಸ್ ಸರ್. ಪಿಪಿಟಿ ಮೋಡ್ ಮಾಡ್ಬೋದು.
ಬರ್ತಾ ಇದೆ.
ಬಂತು ಬಂತು ಬಂತು.
ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು. ಸ್ಟಾಪ್ ಮಾಡ್ಲಾ ಈಗ, ಮತ್ತೆ ಆಮೇಲೆ ಶುರು ಮಾಡ್ಲಾ?
ಎಸ್
ಓಕೆ
stop
ಸರ್,
ಮಾಡಿ.
ಫಾರ್ಮಲ್ಲಿ ವೆಲ್ಕಮ್ ಶುರು ಮಾಡ್ಬಿಡಿ ಸರ್.
ಸ್ಟಾರ್ಟ್ ಮಾಡಿ.
ಸ್ಟಾರ್ಟ್ ಮಾಡಿ.
ಶುರು ಮಾಡೋಣ ಸರ್.
Yes.
Sir, we will start, sir.
ಆಯ್ತು ಮಾಡಿ.
ಶುರು ಮಾಡಿ.
ಎಲ್ಲರಿಗೂ ಶುಭ ಮುಂಜಾನೆ. ಮಲೆನಾಡಿನ ಹೆಬ್ಬಾಗಿಲು ಶಿವಮೊಗ್ಗ ಜಿಲ್ಲೆಯಲ್ಲಿ ಅನಾವರಣಗೊಂಡ ರಾಜ್ಯದ ಮೊಟ್ಟಮೊದಲ ಕೃಷಿ ಮತ್ತು ತೋಟಗಾರಿಕೆ ವಿಶ್ವವಿದ್ಯಾಲಯವು
Enable ಮಾಡ್ತಾ ಇದ್ದೀರಾ?
ತನ್ನ ಸಾರ್ಥಕ 7 ವರ್ಷಗಳನ್ನು ಪೂರೈಸಿ 8ನೇ ವರ್ಷಕ್ಕೆ ಕಾಲಿಡುತ್ತಿರುವ ಈ ಸುದಿನದಂದು ಆಯೋಜಿಸಿರುವ ಸಂಸ್ಥಾಪನಾ ದಿನಾಚರಣೆ ಅಂತರ್ಜಾಲ ಕಾರ್ಯಕ್ರಮದಲ್ಲಿ ಭಾಗವಹಿಸಿರುವ ಎಲ್ಲ ಅತಿಥಿ ಗಣ್ಯರಿಗೆ, ವಿಶ್ವವಿದ್ಯಾಲಯದ ಗೌರವಾನ್ವಿತ ಕುಲಪತಿಗಳಿಗೆ, ವ್ಯವಸ್ಥಾಪನಾ ಮಂಡಳಿ ಸದಸ್ಯರುಗಳಿಗೆ, ಅಧಿಕಾರಿ ವೃಂದದವರಿಗೆ, ಬೋಧಕ ಹಾಗೂ ಬೋಧಕೇತರ ಸಿಬ್ಬಂದಿ ವರ್ಗದವರಿಗೆ, ನೆಚ್ಚಿನ ವಿದ್ಯಾರ್ಥಿಗಳಿಗೆ, ವಿಶ್ವವಿದ್ಯಾಲಯದ ಹಿತೈಷಿಗಳಿಗೆ ಹಾಗೂ ಕಾರ್ಯಕ್ರಮವನ್ನು ವೀಕ್ಷಿಸುತ್ತಿರುವ ಎಲ್ಲ ಆಹ್ವಾನಿತರಿಗೆ 8ನೇ ಸಂಸ್ಥಾಪನಾ ದಿನಾಚರಣೆ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಆತ್ಮೀಯ ಸ್ವಾಗತ. Very good morning to distinguished guests and invitees of 8th Foundation Day program. The University of Agricultural and Horticultural Sciences Shivamogga came into existence from September 21st, 2012. Is the first of its kind university, integrated university in the state, located in the Malnad region of Karnataka amidst nature's most beautiful landscape and waterfalls. On successful completion of 7 years of its establishment, university is celebrating its 8th Foundation Day today. You are all welcome to today's function organized here this morning. May I now request our Honorable Vice Chancellor Dr. M.K. Nayak sir to preside over this function. Distinguished chief guest of today's function, Padma Shri Dr. A.S. Kiran Kumar, former chairman, Indian Space Research Organization, Bangalore, will be joining us through online and deliver the Foundation Day speech later in this program. Welcome to you, sir. ವಿಶ್ವವಿದ್ಯಾಲಯದ ಎಲ್ಲ ಗೌರವಾನ್ವಿತ ವ್ಯವಸ್ಥಾಪನಾ ಮಂಡಳಿ ಸದಸ್ಯರು ಕಾರ್ಯಕ್ರಮದಲ್ಲಿ ಮುಖ್ಯ ಅತಿಥಿಗಳಾಗಿ ಭಾಗವಹಿಸಲಿದ್ದಾರೆ. Now, to formally welcome all of you, may I now request the respected registrar of the university, Dr. M. Dinesh Kumar, to officially welcome all the dignitaries and invitees of today's function, followed by presentation of university profile, besides a brief introduction of our valued chief guest of today's function.
Good morning to one and all, and welcome for this occasion. It gives me an immense pleasure to be the part of 8th Foundation Day along with you all for the occasion. First of all, it is my duty to welcome our Honorable Vice Chancellor, Dr. M.K. Nayak sir, who is a guide, philosopher, and a motive force behind each successes, also presides over this function. Sir, on behalf of all, I sincerely welcome to you for this occasion of 8th Foundation Day. It is a unique day for us, wherein we have with us a great personality who always behind hard work brought India into the wheels of rapid development in the field of aeroscience and native of our pride Karnataka. It is none other than Padma Shri A.S. Kiran Kumar sir, who served as a Secretary, Department of Space and Chairman for ISRO. University is grateful to you, sir, as you accepted our invitation as a chief guest for this occasion. On behalf of university and all of us, my heartfelt welcome to you, sir. ಆದರಣೀಯ ಸ್ವಾಗತವನ್ನ ನಮ್ಮ ವಿಶ್ವವಿದ್ಯಾನಿಲಯದ ಎಲ್ಲರ ಪರವಾಗಿ ಕೋರುತ್ತಿದ್ದೇನೆ. ಸುಸ್ವಾಗತಗಳು ಸರ್. It is my privilege to extend my welcome note to our board of regents, who actually takes a note and directs our university in a right path. ಆಡಳಿತ ಮಂಡಳಿಯ ಪ್ರತಿ ಸದಸ್ಯರಿಗೂ ಕೂಡ ನನ್ನ ಆತ್ಮೀಯ ಸ್ವಾಗತವನ್ನ ಕೋರುತ್ತಿದ್ದೇನೆ. To begin with, our additional chief secretary, Department of Agriculture, Dr. Rajkumar Khatri sir, and the office staff of that agriculture department, then ISN Prasad, additional chief secretary, and the office staff, then principal secretary Dr. Rajendra Kumar Kataria and the office staff. Sir, on behalf of the university, I welcome you all, sir. Then to name it, we are having Ramesh Agde sir, then Dr. M.H. Chandrappa, then Dr. M.H. Krishnamurthy, Dr. V.K. Arun Kumar, who joined recently, Dr. B. Shivaram, who also joined recently, then ICR nominee Dr. S. Bhaskar, and our own Dean, Dr. C.J. Kushalappa, who actually directs us in many directions for the university. Sir, on behalf of all, I once again welcome you, sir. Then on this occasion, it is my pleasure to welcome our different ICR institute heads and the other staff members. Welcome, sir. Then I also welcome on behalf of university all the vice chancellors, registrars, and other key officers of the other foreign universities. And it is my privilege to extend my welcome note to the department friends like JDS, DDs, ADS of different forms, that is agriculture, horticulture, fisheries, sericulture, forestry, and all others. I take this opportunity to welcome all the members and as well externals of the Board of Studies, UG, PG, and Academic Council. I feel it is a great opportunity for me to welcome all our staff members who recently retired, including officers and also those who are viewing this function. ಆತ್ಮೀಯ ಬೆಸುಗೆಯಲ್ಲಿ ಎಲ್ಲಾ ಮಿತ್ರರು ನಮ್ಮೊಂದಿಗಿರುತ್ತಾರೆ. ವಿಶ್ವವಿದ್ಯಾನಿಲಯದ ಎಲ್ಲ ಅಧಿಕಾರಿ ವೃಂದದ ಮಿತ್ರರಿಗೆ, ತಾಂತ್ರಿಕ ಅಥವಾ ಬೋಧಕ ವೃಂದದ ಮಿತ್ರರಿಗೆ ಹಾಗೂ ನನ್ನ ಸಹೋದ್ಯೋಗಿಗಳಿಗೆ, all professors, associate professors, assistant professors, research assistants, and technical assistants, it is my profound duty to welcome for this occasion. ಯುದ್ಧಗಳಲ್ಲಿ ಸಾರಥಿಯ ಪಾತ್ರ ಅತಿ ಮುಖ್ಯವಾಗಿರುತ್ತದೆ. ಸದಾ ನಮ್ಮ ಒತ್ತಾಸೆಗಳಿಗೆ ಬೆಂಬಲಿಸುತ್ತಾ ಹೆಗಲು ಕೊಡುವ ಎಲ್ಲಾ ವರ್ಗದ ತಾಂತ್ರಿಕೇತರ, ಬೋಧಕೇತರ ವೃಂದದವರಿಗೂ ಹಾಗೂ ಅತಿ ಮುಖ್ಯವಾಗಿ ಕೃಷಿ ಕಾರ್ಮಿಕ ವರ್ಗಕ್ಕೂ ನನ್ನ ಆದರಣೀಯ ಸುಸ್ವಾಗತವನ್ನ ಈ ಸಂದರ್ಭದಲ್ಲಿ ಹೇಳಬಯಸುತ್ತೇನೆ. ಅಂತೆಯೇ ಇದಕ್ಕಾಗಿ ನಮ್ಮ ಪ್ರೆಸ್ನವರು ಮತ್ತೆ ಛಾಯಾಗ್ರಾಹಕರು ಈ ಸಮಯದಲ್ಲಿ ಹಾಜರಿದ್ದು ನಮಗೆ ಅವರ ಸಹಾಯ ಹಸ್ತವನ್ನ ನೀಡಿರುತ್ತಾರೆ. ನಿಮ್ಮೆಲ್ಲರಿಗೂ ಸುಸ್ವಾಗತವನ್ನ ಹೇಳಬಯಸುತ್ತೇನೆ. ಕೆಲವೊಮ್ಮೆ ಅದೃಷ್ಟ, ಕೆಲವೊಮ್ಮೆ ಪರಿಶ್ರಮ, ಕೆಲವೊಮ್ಮೆ ಸಮಯ ಪ್ರಜ್ಞೆ, ಹೀಗೆ ಒಂದು ಕೆಲಸದ ಹಿಂದೆ ಪ್ರತ್ಯಕ್ಷವಾಗಿ ಇಲ್ಲವೇ ಪರೋಕ್ಷವಾಗಿ ಕಾರ್ಯನಿರ್ವಹಿಸಿರುತ್ತಾರೆ. ಹಲವಾರು ಮಂದಿಗಳು ಇರುತ್ತಾರೆ, ಸಹಾಯ ಹಸ್ತವನ್ನು ನೀಡಿರುತ್ತಾರೆ. ಪ್ರತಿಯೊಬ್ಬರಿಗೂ ಕೂಡ ಈ ಸುಸಂದರ್ಭದಲ್ಲಿ ನನ್ನ ಸುಸ್ವಾಗತವನ್ನು ಹೇಳಲು ಬಯಸುತ್ತೇನೆ. I am now very much pleased to share before you the profile of the university in brief. University of Agriculture and Horticulture Sciences is the first integrated university in the state which covers agriculture, horticulture, forestry, and other related sciences under its purview. It covers heavy rainfall areas of coastal belts to that of low rainfall belts, having jurisdiction of 7 districts almost in the middle part of the state. As we aware, university has 6 educational institutes, each college of agriculture and forestry, 2 colleges of horticulture and diploma agri. It is an honor and a pride that UAHS and its 4 constituent colleges have been accredited and recognized by National Agricultural Education Accreditation Board, ICR, which is valid till March 2021. University is ranked presently 21st among the farm universities by the ICAR. Further, Indian Council of Forestry Research and Education has accredited College of Forestry Ponampet with A++ ranking and is rated as one of the best 5 colleges in the country. UAHS is ranked 4 stars by the ranking of Karnataka State Higher Education Council. University has secured second highest position in postgraduate scholarships in horticulture and forestry at all India level during the year 2017-18 and 2018-19 consecutively. During the present year, that is the previous year, during 1920, among the students, 15 students have got ICR JRF and 12 students have got ICR SRF. Apart from this, there are 21 students who enrolled as ARS scientists, 13 students as officers with Indian Forest Services, 3 students in the Indian Armed Forces as officers, then other 3 with other UPSC selections. 3 students have been awarded Netaji Subhash ICAR International Fellowship for pursuing doctoral studies outside the country. Miss Vidyashri AS, PhD student from Department of Agriculture Entomology, was awarded ICR Jawaharlal Nehru Best Thesis Award for the outstanding contribution. Since inception, a total of 1,827 students have been graduated in agriculture, horticulture, and forestry discipline, whereas university issued 140 gold medals to different UG and PG students. The achievement by our students in the field of cultural and sports event is also quite remarkable. To say an example, in the recently held 18th ICR India Inter-Agricultural University Youth Festival, our team achieved runners-up, that is second. Sir, university is blessed with very much diversified agri and horticultural crops and covers natural forest area including Western Ghats. To cater the research needs under university umbrella, 9 agricultural and horticultural research stations are located at different centers and are situated, and are covering 4 agroclimatic zones. For the benefit of farmers, till this date, university has released the following high-yielding varieties in different crops. For example, for paddy 13, wherein it includes Sahyadri Suma for hill zone, Sahyadri Panchamukhi for coastal zone, Sahyadri Bharat for zone 9, and Sahyadri Madhu for zone 7. And cashew nut, as you aware, Ullan series is one of the very grand series that what we are releasing, and till now we have released 6 numbers. So like that, in cardamom 3, groundnut 3, areca nut 1, sesamum 1, castor 1, and in tobacco we are having 2 high-yielding varieties for the purpose of the farmers. Now, apart from this also, 83 productional technologies, 62 protectional technologies, 17 farm mechanization interventions, then 18 horticultural technologies, and 11 inland fisheries technologies have been released for the benefit of farmers. University has filed 2 applications for patents also. To facilitate research, we are having 3 centers of excellence. To name them, Pesticide Residue Testing Laboratory, Diagnosis of Plant Diseases and Pests, and Climate Resilience. Farm Mechanization Training and Testing Institute is situated at Hiriyur, and as a substation, we are also having Brahmavar, wherein we are having a very good work to name Brahmavar model of paddy weeder has been released, then modified hand-operated maize sheller is being released, then power tiller with certain modifications to shoot the farmer's end. We are releasing all these technologies from that end. University also hosts Southern Regional Center of PPV and FRA that caters the need of 6 states. The functioning unit of extension services, sir, in the university is very strong and has adopted for the farmers, from the farmers since beginning. To meet the needs or the requirement of farmers very effectively, university has 4 Krishi Vignana Kendras and 2 extension education units which takes care of extending the research technological knowledge to the practical fields. Conducting timely need-based different training programs both at field level and at university level, demonstration related to recent aspects like seed village concept, IFS, nutri gardens, organic farming, doubling the farming income are being successfully organized apart from direct contact with the farmers to solve the field-oriented problems. On the routine basis, all research stations, they host annual Krishi Mela to disseminate the knowledge, and every year farmers from each district is honored for their more production in crops. From university, we are having a Kannada monthly magazine, Negila Medita, which is distributed to the farmers. And from All India Radio also, we are having 2 programs, that is Negila Medita and Krishi Samruddhi. For the input dealers, we are having Deshi training programs since last 8 years. And we are also having a single window concept like Agriculture Technology Information Center ETIC to serve farmers. Apart from that, we are also having our Raitanadi app wherein in the local language ಕನ್ನಡದಲ್ಲಿ ಅದನ್ನ ನಾವು ಫಾರ್ಮರ್ಸ್ಗೆ ಕೊಟ್ಟಿದ್ದೇವೆ ಅವರ ಕಡೆಯಿಂದ ಮತ್ತೆ ನಮ್ಮ ಕಡೆಯಿಂದ ಮ್ಯಾಟರ್ ಡಿಸಿಮಿನೇಟ್ ಆಗಲಿಕ್ಕೆ. Sir, it is now my privilege to introduce Padma Shri A.S. Kiran Kumar sir. Sir, presently, sir is 68 years old and he is very dynamic and active. Now, presently, he is engaged as a member of the Space Commission, Government of India, and member of the Governing Council of Indian Institute of Science, IISc, Bangalore, and also President of the Aeronautics Society of India. You can able to understand the magnanimous role that the sir is playing even with this age also. He has successfully worked in many important spheres such as Earth observation, communication, navigation, meteorology, and space sciences, which has facilitated our country for the rapid development. The major contribution to the science from him is design and development of more than 50 electro-optical imaging sensors flown on spaceborne platforms since from Bhaskara to the recent Mars orbiter mission up to 2030. He has played a crucial role in Chandrayaan-1 mission right from the conceptualization stage and has made exemplary contributions to the success of Mars orbiter mission and, most important, reusable launch vehicle technology demonstrations. Now, as a course of his journey, he has involved in various committees. To name one or two, he was the chair for the Committee on Earth Observation Satellites, and he is the expert team member on the satellite systems of the World Meteorological Organization, and also member for the Indo-US Working Group of Civil Space Cooperation. Moving to his dedicated work, he has been awarded as fellow from as many as 10 academics or 10 societies. To name some of them, Indian National Academy of Engineering, National Academy of Science India, Indian Society of Remote Sensing, and so on. He has been conferred with honoris causa and DSc by 18 different Indian academic institutions. Now, having such a beauty of work structure and other things, the awards, as many as dozen awards he has been conferred for his contributions, and to name few of them, he was conferred Padma Shri Award by President of India in 2014. Karnataka government also honored him with Rajyotsava Award in the year 2015. Apart from that, the most prestigious 2018 International Von Karman Wing Award has been given to him by the Aerospace Historical Society. Now, the highest civilian honor also gained by the government of France has been declared that. Sir, by accepting our invitation, I reiterate that we are delighted or graced by your presence for the occasion, sir. Thank you, sir. I thank profusely the organizers for giving me the opportunity to share about my university and as well introduce the chief guest apart from routine welcome note. Thank you one and all. Jai Bharat Mate, Jai Bhuvaneshwari.
I thank Registrar of the University for warm welcome address with brief presentation of university achievements. Besides presenting such glittering and an outstanding set of achievements of our esteemed chief guest. On the occasion of Foundation Day, it's now time for us to pay attention to hear Foundation Day lecture on India in Space with special reference to agriculture by our esteemed chief guest, Padma Shri Dr. A.S. Kiran Kumar, former chairman, Indian Space Research Organization, Bangalore. It is indeed an honor for me to invite Padma Shri Dr. A.S. Kiran Kumar to deliver Foundation Day lecture. Over to you, sir.
Thank you very much. At the outset, I would like to thank the Vice Chancellor, then all the Senate members for giving me an opportunity to be amongst you on the 8th Foundation Day of this integrated university, one of the unique places where agriculture and horticulture is getting integrated and work is in progress on that. Thank you very much for this opportunity. And let me also compliment the institution for establishing a name in its very short existence of 8 years. And what it has already achieved is quite significant. And one more thing also we need to appreciate that any activity which is started afresh, it is the initial years which makes a huge difference to the way the organization grows and the organization develops. And what has been done in these 7 to 8 years is quite remarkable. If you look at what India has done itself in the space program, we are all indebted to a great visionary scientist, Dr. Vikram Sarabhai, who integrated the whole of last year. And it was, in fact, his vision which enabled India to actually become part of this space technology usage for countries' development. I would like to just give a couple of views what he had expressed, share with you. A positive approach out of our predicament lies in finding solutions where the particular disadvantage of developing nations, which is that they have little to build on, is made an asset rather than a liability. You can imagine this was in the 50s when India had just about 10 years of independence. And it was at that time he was looking at use of space technology for countries' development. Another very interesting thing which he pointed out was our national goals involve leapfrogging from a state of economic backwardness and social disabilities, attempting to achieve in a few decades a change which has historically taken centuries in other lands. This involves innovation at all levels. So in fact, it was his vision of making use of space technology for national development, encompassing capability demonstration, capacity build-up to meet the national and societal demands, and to be a significant player in space economy. Many of you are quite aware that way back in 57, when the Russians put their first object into space, it was Dr. Sarabhai's idea of looking at how this technology can be used in our country. And starting from that time, what India has achieved today is we have completed 75 launch vehicle missions, starting from sounding rockets way back in 63. And we have 50 launches of PSLV and our own indigenously developed cryogenic engines, more than 109 satellites of India. And in the process, we have also launched 321 satellites of 33 countries, showcasing that we are able to actually make use of our capability for putting satellites of other countries also into orbit. If you look at space, space-enabled strategies for national development, space infrastructure and space convergent technologies, space application in satellite communication, remote sensing, meteorology, navigation, space science, and all of this serving as a growth engine for ensuring sustainable development, providing inputs for community empowerment and governance. And just one example I would like to give of how Dr. Abhai's ideas were put into practice fairly quickly. On the left-hand bottom side, you see a church, and it was in fact in that church, the first assembly of sounding rockets was done by the country way back in 60s. When this had to be done, Dr. Sarabhai had to convince the fishermen in that place, Tumba, telling them, if you vacate this place for us today and allow us to conduct these experiments, one day in future, the country will benefit. Just as though to demonstrate what he had told, from 1999 onwards, India is able to provide to its fishermen in the 7,500 kilometer long coastline specific information about where to go for fishing by observing ocean color from space, by looking at the color of the ocean in 8 different spectral bands, identifying the chlorophyll, and through the chlorophyll, the food chain of the fish, and then specifically locating the possible place where if fish catching can be beneficial. And this is being disseminated through Indian National Center for Ocean Information System from 1999 onwards. And this act alone saves to the country because the fisherman now doesn't have to search, spend extra time, and also save on petrol and diesel almost 15 to 20,000 crores a year. To this, the country added a new capability with its navigation satellites, where a small gadget which is fitted into the boat of the fisherman, and then a mobile in the hands of the fisherman. The mobile itself does not require any connectivity to terrestrial towers, but through Wi-Fi or Bluetooth, it communicates with the small gadget on the board and gives him in a video compass mode direction to the prospective fishing zone. And also in his mother tongue, it provides him specific information about weather vagaries that could approaching international boundary. So you can see here the use of space technology, the most advanced technology of building launch vehicles, rockets, satellites, and then the various instruments. A person who does not know reading or writing is able to make use of the technology for his day-to-day living. And then another very important thing that has happened is in the weather. By making use of the various satellite observations we have in geostationary platforms and microwave sensors, the cyclone tracking and prediction has become available, and the information about heavy rains and all this is possible through the use of the space technology based observation. During the last few decades, India has built its communication satellites starting from INSAT series. Today, we have more than 15 satellites providing us inputs on communication, connectivity, teleconnectivity, or in terms of whether it is ATMs and direct to home and other things. Now, satellite navigation, we have a navigation satellite, a 7 satellite constellation of our own, which is very different from what Americans, Russians, Chinese, and Europeans have done. With only a 7 satellite constellation, we are able to provide the information on a handheld device of latitude, longitude, and this also forms the backbone of our navigation system, which is being extensively used today. Now, in all this, looking at how the agriculture is actually getting benefit from the space technology. Way back in 70s, Professor Pisharati conducted an experiment called coconut root wilt disease in Kerala, where he borrowed a camera from American institutes, and then it was flown on an aircraft using false color infrared imaging. And using those aircraft images, he demonstrated that it is possible to identify the root wilt disease, extent of that disease that is occurring in the plantation of the coconut. And then based on that, we were able to actually get onto the remote sensing activity in space. And then subsequently, a balloon-based resources inventory experiment was conducted, which was followed up with thermal infrared imaging. And then this paved the way for our Indian remote sensing satellite series. And then starting from the early 70s, the 79, when the first opportunity to put a remote sensing satellite was provided by the Russians using Bhaskara, then from then onwards, consistently, we have been improving our capability to monitor Earth in different spectral bands, in different resolutions, both temporal and spatial. Today, we have about half a dozen to dozen satellites, both operating in low Earth orbit and geostationary orbit. We cover from resolution of sub-meter to kilometers and the entire Indian subcontinent in a few seconds. And all these capabilities have been built and they form the backbone for the remote sensing and the activities which I'll be touching upon subsequently. Similarly, in providing inputs for meteorological weather forecasting activities, we have a series of satellites which cover both optical, infrared, as well as microwave, because you will be wondering during the monsoon period between June and September, if you start looking from space towards Earth, you will be covered with clouds most of. So what can we see when you look from space? But then, like, we can see through glass in a transparent manner. Microwave signals can penetrate through the clouds, and you can see that. So using microwave sensors, we have ocean wind vector information and also many other inputs that are generated using these satellites. And another important development that's happened is hyperspectral. Like if you different bands, you get many details. By looking at hyperspectral, that means in very narrow band, fine spectral resolution, you can study the various crops, you can study them for their crop pests, and then the bigger various activities. We have been building instruments for hyperspectral observations also. And then currently there is a series of data collected to serve as the actually backbone for the future studies of hyperspectral imaging. A American institute developed an instrument, was flown on an aircraft, and we have collected spectral signatures over many parts of the country. And in fact, this data is also available for academic institutions to study and come up with various results. For example, wheat rust disease identification using hyperspectral data has been demonstrated, and a large number of such activities can also be done using hyperspectral observations, which enable the agriculture and weather activities. We also have a satellite today which provides us certain hyperspectral information in visible, near infrared, and shortwave infrared signals. And the application of this hyperspectral agriculture is from short to long. There is a tremendous opportunity here, and more such data is also accessible and available. Like I said, microwave, we can see through the clouds, and this gives us an advantage. And another specific aspect of microwave sensors is, see, when we take picture from a mobile or a camera during daylight, sunlight is the source of illumination. And then during night or no illumination time, this will not work. So you need a flash of your own. In the same way, microwave sensor carries its own source of information, source of illumination, and you can make observation satellite-based observation, you also need to make a large number of ground observations, like agro-meteorological stations, which enable us vegetation response to climate or carbon dioxide uptake, sensors for radiation balance, automatic weather stations, which are established at many different places, atmospheric boundary level networks, wind profilers, Doppler weather radars, and then carbon flux tower. So in this manner, we also develop a large number of in situ observation for carrying out the activities of remote sensing. In a sense, today what happens is space technology inputs for all this. You have a set of optical and microwave, multispectral and hyperspectral, multi-temporal. That means you can also see, for example, from our geostationary satellite, an area of 100 kilometer by 100 kilometer at about 60 meter resolution. You can see multiple times in a second. And then there are other places where you can cover them over large areas. So you have got these multispectral data. Then using our own data, digital elevation models have been created. Then using our navigation satellite, position information is generated. And using all these computers and models for applying them for socio-economic security, sustainable development, disaster risk reduction and governance, in all these areas, activities are possible today. And towards this, there was also an activity which was conducted to familiarize people from both state and central government departments. And an activity was done at national level to showcase how space technology can be used for various applications. This was done a couple of years back as a forerunner for improving the use of space technology for various activities. Here you can see some of the examples of the type of the data that can be collected and how it can be draped on digital elevation model, and also how you can actually correct for atmospheric pollution and other things in data processing. Similarly, you can see resource series of satellite, how data can be used for different types of application and the kind of processing that can be done using this data. Then similarly, you can use it for change detection, and then there are techniques for immersive visualization. And using all this, it's possible to carry out whether it's urban sprawl studies or monitoring of different portions for different activities. These are just examples of how activities can be done. And then you can also do air quality monitoring from space using a geostationary satellite. And also you can see whether the sandstorms coming from the Gulf countries reaching up to Bombay or other places where due to the pollution, air pollution, how the air quality gets affected. And then this is another example of how such things can be processed and corrected for image processing. And then you can also cover different regions of the globe, not only India, but also North Pole and South Pole. And here what you are seeing in this particular image is you are familiar that the ocean covers 3/4 of the globe. And for weather monitoring, if you are able to get ocean wind vector information, specifically for that, the entire weather forecasting community gets huge inputs for that. India is contributing to the international component of numerical weather forecasting by providing, using our satellite data, the ocean wind vectors. And this is used not only for global studies, but also for our own India Meteorology Department data analysis and different types of synthetic aperture radar data, how it is used, it's shown. Here also you can see an example of how time series studies helps you to see the development that is happening, whether it's in icebergs or in different portions. And we also have developed airborne instruments, which are actually being used for today, not only in India, but also even in USA, because like we borrowed the average instruments from the Americans. See, actually in a program called the Indo-US Cooperation, the L and S band synthetic aperture radar developed by us is actually flown over America, and they are using this data for as a precursor to do the studies on future NASA ISRO synthetic aperture radar, which is going to provide imaging data in L and S band, and which is going to provide us both for agriculture, for by estimating the biomass, forestry, and also on geological studies. So this is the kind of satellite that is under development, and this is expected to be flown early 2022. And here is an example again of how actually the glacier melts and lake gets formed. And by continuous studies year after year, you can study how the changes happen. And then using the satellite data, you can also find out the various, whether it's about solar energy inputs or wind energy, ocean energy, all these studies can be carried out. And INSAT 3D provides a series of data which helps us in rainfall map on a regular basis, and also used for forest fire detection, and then providing the various things. Now coming specifically to the various agricultural input activities that has happened, right from, like I said, starting from the coconut wilt disease studies, progressively using the remote sensing data, India has been working on how to make use of it for identifying the crops and crop forecasting. And today, from 2012 onwards, a center in Delhi called Mahalanobis Crop Forecasting Center has been established. And before that was established, almost 45 years of use of space technology, and then continuous demonstration of this using the program. Initially it was called CAPE, then FUSL, and then today the activities are being carried out in the Mahalanobis Crop Forecasting Center, which is actually now doing in the programs called FUSL, which using that crop forecasting of 9 major types expected to be extended to almost 20 types shortly. Then the drought monitoring and assessment, and then for horticulture crop assessment, crop insurance, crop intensification. In all these areas, today this particular MNCFC is working. And then today, for example, work is in progress for increasing the number of crops from 15 to 21 using whether it's Kharif rice or Rabi or different types of harvest thing being told month in advance, 2 months in advance to the government so that appropriate planning can be done. So similarly, if you see, they make use of multi-data of advanced wide field sensor or RISAT, and then similarly from other sources that the data is available. By making use of this, they carry out, in addition to actually onboard or satellite-based data, the ground truth collection is also done. And even for planning this crop cutting experiment, the satellite data is used to identify in which particular areas the crop cutting experiments have to be done. And progressively, this is becoming more and more the field-based with crowdsourcing. Today, probably even Karnataka government, you would have seen recently, is trying to make use of mobile-based images taken by the crop, even farmer, and then uploading that data and how it can be used for enabling actually the studies and then the forecast activities what are done. And then even horticultural crop inventory and site suitability studies, this is also done basically using area assessment, production forecast, and then development and management, site suitability analysis, post-harvest infrastructure development, then intensification and rejuvenation. In all these areas, whether it is for chili and cotton, even in Karnataka, then crop identification, yield modeling, a host of such activities are being done using satellite-based input, and also the information generated from in-field, like banana in Tirunelveli, chili in Prakasham, citrus in Mehsana, and then like that, onions in Nasik. So all these activities are being done using the program called Chaman. And then today, the Space Application Center, along with MNCFC, is also working on this. And there are opportunities available for academic institutions to become partners in this and work towards that. 8 data sets for the northeastern states of 6 crops. This is being done. And then geospatial development planning and horticulture. These are some of the activities that are going on this Chaman program. Similarly, a large amount of geospatial applications are being done on horticulture activities, whether it is aqua horticulture assessment in Bihar, and the satellite-based inputs which MNCFC is doing is for area correction factor, smart sampling, then area discrepancy, yield dispute resolution, and then prevented sowing, failed sowing, seasonality, clustering of districts. All these things go as inputs for the various activities that are done. Smart sampling, which is done in Jharkhand. There's an example shown by MNCFC. And then similarly, crop intensification in rice fallow areas, which is carried out, study in 6 states of Assam, Bihar, Chhattisgarh, and then rice mapping using SAR, then suitability analysis. In addition to this, agricultural drought vulnerability assessment is one of the activities which is done again in MNCFC and also other the remote sensing application center across the country. And it is based on the exposure, sensitivity, adaptive capacity, and then making use of the agricultural drought index, a multidimensional quantitative approach for measuring crop generic agricultural drought vulnerability status at sub-district level. These are the things that are possible on this, and this is one of the examples of the Telangana state. What has been done is shown here. And then again, disaster and damage assessment. This becomes important for various activities in addition to crop assessment, post harvesting, and also for providing inputs to the insurance and the likes. This is again drought portal of MNCFC, how it looks and what it shows. Then disaster risk reduction is again another very important aspect where the integrated water monitoring program, or you can locate the eroded areas for soil conservation or salt affected area identification. And then using the Manrega program, the inputs are generated and it's utilized for various activities here. Then providing safety nets for building resilience. This is technology as a game changer. If you look at this particular aspect, see, it is able to provide timely claim settlement. Then it can provide inputs for all these activities. It can provide tools in mobility, GIS, remote sensing, and it can provide post-harvest damage inputs, weather indices, mobile apps, field enumeration, then localized crop damages, hailstorm, post-hailstorm assessment, crop damage, whether it is natural or abnormal events, crop assessment, crop monitoring, enrollment, emission, and then compliance, and also rate making, agricultural risk info maps, and past insurance data. Based on all this, the work is being done. And similarly, using aquaculture planning in village and water boundaries. So here again, you will see in a subsequent slide, using the satellite data, you are able to generate surface water cover maps of the country once in a week or once in 10 days. And making use of this, you can identify the places which are available, sufficient water is available over a period of time, and how those in water bodies can be used for inland fisheries. And such activities have been carried out using this aquaculture planning in village water bodies. And these have been used for sustainable activities by the rural tribal development ministry, etc. So this is an example which shows surface water maps can be generated using satellite data on a regular basis, and then using that the information can be generated. And then water spread and reservoir capacity, these are also generated on a continuous basis. Then in addition to this, of course, over a period of decades, groundwater prospects, mapping using satellite data, identifying potential areas where drilling can be done, what could be the kind of yield that is present. These are some of the activities that have been carried out for a period of time, encompassing the various data sets, like I said, groundwater prospects. And then this makes use of satellite data as well as the subsequently field studies which are done on the specific sites. And today, one other activity that is being done on a large scale is space-based information system for decentralized planning, what is called SIS-D program, which is helping actually empowering communities at grassroots level, geospatial data, satellite imagery, up to 2.5 meter data or cadastral data, then using census data, which makes use of population, then the literacy rates, then housing condition, climate data, and also assessing asset inventory. And in this program, what is being done is actually making use of academic institutions, even in Karnataka, in actually in Mangalore, we had a complete district covered by a set of students and teachers. They created the database for the entire district. And similarly in Rajasthan, and more use of student group and academic institutions in establishing this database for Panchayat level planning is being done. Then in addition to all this, there is an opportunity for academic institutions in places like what we have in Ahmedabad, in NRSC and other places where the advanced microwave technique development for forestry application, for soil moisture retrieval, and similarly, today, satellite-based agromet advisories to farmers through value-added products is one of the activities that is being done. And IMD is actually disseminating through the mobiles various inputs to the various farmers on different aspects. And similarly, space-based technology usage for agro-industries, whether it is dairy, even availability of fodder. ISRO is working with Amul and then NDDB in Gujarat for establishing the availability studies of fodder, and similar thing, whether it is sugar for food processing, for crop insurance. In all these areas, there is tremendous amount of work that needs to be done, which can be part of the work that agriculture and horticulture institutions like yours can take up and participate. I'll show in the subsequent slide the kind of opportunities that are available in various institutions with ISRO and the central governments. Then similarly, if you look at even some of the work that has been done earlier using tax claim settlements for agricultural activities, this again using multi-date data, the computation of NDVI, and continuously based on time series data, this lot of information gets generated and can be used in various application activities. And then this is another space technology for utilization of food security, agricultural assessment monitoring, SOPALAM. This also based on earlier projects that was done even in Karnataka has been demonstrated, and themes like crop inventory, crop yield modeling, crop stress and agro advisory. In all these areas, there is work that is being done in various institutions under different programs. So MNCFC, in fact, is actually providing these activities in sharing ground truth and satellite data for R&D work. And the form is available in the MNCFC website. It has got an internship program where 1 to 3 months for Indian national pursuing MSc, MTech or BTech or in relevant fields, and then recognized university and institutions, MTech, MSc, dissertation activities, and then also regularly they hire analysts from various disciplines, agriculture, remote sensing, and on contractual basis. In addition to that, in Space Application Center, you have a website called Vedas, which actually provides Earth observation information, polar science, and then it provides not only data of the Indian satellite, but also of other satellite, and even planetary science information is available for hydrological science application, glacier information system, then vegetation and crop monitoring. You can do host of activities using this Vedas. Similarly, there is a website called MOSDAC, that is Meteorology and Oceanographic Science Data Archival Center, which provides data collected from our own satellite, but also from satellites of the other space agencies, which can be used for various studies. Similarly, Bowen is another place where you have got the data available of all the satellites that have been taken. Today, Bowen has got 11 ISRO center nodes, state remote sensing node, and other ministry nodes, which actually provides a host of high resolution data and the various activities. So this is another web that is available, platform that is available for activities. Similarly, Vedas I just talked to you about already. Then MOSDAC has a program called SMART. It is one of the ISRO initiative to promote research in satellite meteorology and oceanography, and also for the inputs, how this oceanography and atmospheric inputs can go into the various horticulture and then ocean-based fisheries and other studies that can be done. For all this, there is an opportunity here, both for research initiation programs, advanced research programs, and also data exploitation programs. Training activities are done, and on a regular basis, the activities are done in these centers, and the institution can actually tie up with them and make use of it for enabling more and more studies that can be done. Now, in fact, what I have tried to do is just to try and give you a glimpse of the activities that are being done in the country using the space technology. And space technology today, making use of it, the availability of opportunities in institutions like the University of Agriculture and Horticultural Sciences, there is a tremendous opportunity, because today the availability of geospatial inputs and space inputs can form a very significant component of the future developments, because today many of you are quite familiar. There are sites where from your mobile, if you just take a picture of a plant, then through the web, you can get to know the crop, that particular plant's vigor, its health, and if you need to give some treatment to that plant for ensuring its health, what kind of inputs are needed to be provided. So in fact, here, a large number of Indian agricultural institutions have worked with a German institute to enable this to happen. But then the opportunity is tremendous because today the actual wisdom of the type of crop that exists and the type of crop changes that occur, the kind of pests it can get infested with is all actually local and local wisdom. And that is where institutions like yours working with the people, with the farmers, and with the actual field studies, and then making use of years of data available of the past, various studies which can be done, which can help us in understanding how things have performed in the past, how we can benefit from that studies so that future predictions and forecasting is possible. In fact, the enabling of the today's spatial geospatial technologies is precisely that. Just to give you an example, today when the forecasting or cyclogenesis information is provided based on the satellite data of wind vectors and cyclone patterns, almost 1 week in advance it is possible to identify the formation of a particular cyclone. This has been done by studying 40 years of satellite-based data and then doing what you can call machine learning or AI, identifying what type of pattern can actually lead to the future cyclones, and has been done. In the same way, today, by actually working on data collected over last many decades, the requirement is the students and researchers have to work more and more, delve into this data, do data mining, artificial intelligence, and analysis ready information, and make use of it for providing specific solutions to the problems that the farmer is going to face, whether by suggesting to him the type of crops he should adopt, which will be more, you can say, robust. And then there's a tremendous opportunity in all this. And today, India and even ISRO, by virtue of bringing in from space technology, observation capability in various spectral regions, and also the navigation capability, even navigation capability today, like I said, there are systems which are available for the ocean, the fisherman when he is in the ocean, or any handheld device which can be used for locating itself. Say today, for example, Karnataka government, which is trying to make use of the crowdsourcing methodology. Here again, I see a tremendous opportunity for the institution like yours, because this is a recurring activity. Earlier, we were trying to make use of postman for providing specific information about the farm. The idea there was link the postman with the farmer, and postman carries a mobile or a handheld device, take pictures of the farm of that particular farmer, and then through his interaction, provide specific inputs through a website to the place. And there, making use of these multi-date images, people can do the image-based analysis and then proceed. In fact, Karnataka government today is doing a great job, and particularly your institute can take up as a task of actually collecting this crowdsourced data. That means multi-date imaging taken from a simple mobile, both of the crop and also the land itself, and then even soil parameters can be studied. We have a set of sensors which can make measurements of the soil of the different, whether it's soil moisture or different types of sensors. All this data can be pulled together, and then it can be provided from crop assessment as a partner to MNCFC or as an independent activity. So the opportunities are huge and tremendous, and there is a tremendous scope for all these activities. And it is a time for making use of more and more technology tools. So let me take this opportunity to thank the Honorable Vice Chancellor for giving me an occasion to talk to all the people involved in this work, to showcase to them some of the work that is done, the kind of technology that has been developed in the country, And this will become fruitful only when more and more people make use of the data. What space technology can provide to us today is inputs for people to make use of it for decision making and for actually implementing. And it is here that institutions have a great role to play, because you are the people who are actually linking to the actual farmer, and to him, if you showcase how technology can be utilized for his day-to-day livelihood, there is nothing more beneficial than the work that we are doing. So let me compliment the University of Agriculture and Horticultural Sciences for the work they have done in this short period of time, and also reminding them that you have tremendous work to do, you have tremendous scope for doing that. Make use of all the technological inputs that are available and proceed and make use of these capabilities. And let me conclude by again remembering Dr. Vikram Sarabhai, whose vision it was of trying to make use of the latest and advanced technology for bringing solutions to the problems we are facing in the country on a day-to-day basis. So with this, let me again compliment UAHS for the work it is doing and wish them a great success in making use of all the accessible tools for enabling the farmers and the country to meet the demands that whether it is events like COVID, which is again, in fact, just I forgot to mention one thing. Even in times like COVID, it is this technology which helps us in dealing with many problems. And I'm sure you have enough desire and wish to make use of all this in your further activities. Thank you very much. Wish you all the very best.
Thank you very much, sir. It is an insightful and knowledge-filled Foundation Day speech, and I am sure our audience has had much value to take away some of these space technology inputs for the future research in agriculture, horticulture, and forestry sciences. For the information of our chief guest, some of these space technology inputs are already being used by our scientists in the fields of agriculture, horticulture, and forestry sciences in the university in collaboration with Indian Space Research Organization. So your presence in this function is of much value to us. Once again, I sincerely thank our distinguished chief guest of today's function, Padma Shri Dr. A.S. Kiran Kumar. Thank you very much, sir. May I now request Dr. S. Bhaskar, Assistant Director General, Agronomy, Agroforestry and Climate Change, Indian Council of Agricultural Research, New Delhi, and Honorable Member, Board of Management, UAHS Shivamogga, and Chief Guest of today's function to offer some views about this program.
Sir, unmute ಮಾಡಿ.
Good morning. Am I audible? Am I audible?
Yes.
Yeah, okay. Good morning, everybody. Thank you, Dr. Veerana. The most respected Padma Shri Dr. A.S. Arun Kumar ji, Honorable Vice Chancellor Dr. Naik, and many of the officers of the university, and Honorable Board Member is also joined, B. Shivram sir, and other staff members and students who have joined this Foundation Day. In fact, it is a great opportunity for me to be associated with this function. First of all, let me congratulate the university, which has completed 7 years and celebrating 8th Foundation Day. Of course, it was a great learning for me today to listen to great visionary in the space technology, Dr. A.S. Arun Kumar ji. Of course, I have recalled all my forgotten about space technology today. Once in a PD, when I was doing PhD, I have given a seminar on remote sensing and space technology, first of my seminar in 1987 itself. At that time, it was not much developed. Of course, it is advanced. And Dr. Sir has already told that because of machine learning and artificial intelligence and all these things, we could reach to the farmer even to a small holding like in Indian conditions. Of course, I am part of MNCFC forecasting, sir. Every week I'll go there for crop weather watching as a ADG in Delhi, and I'll be listening to the NDA values you have developed. But this thing is that how it could be connected to the soil moisture data, so that once NDA value is connected to soil moisture data, then it can be fully used for scheduling of irrigation. That's where we are losing a lot of water by unnecessarily flooding by the farmers and other things. And this should be further taken up by the space technology and MNCFC like that, so that it's going to not only address the issue of irrigation scheduling, it also saves a lot of water for a country like India. That is one thing. Second thing, coming to the university locational advantage, it covers jurisdiction of the 7 Western Ghats districts, except 2 districts, Chitradurga and Davangere. Of course, it is right now located in the rich biodiversity hotspot, and its first function is to preserve that biodiversity, and without changing much of the biodiversity, how best we can improve the production of agriculture crops there. And it is right thing, since it is an integrated university, there is a lot of scope for integration of agriculture and horticulture crops, and by combining the livestock also, without losing much of the biodiversity value. That is one thing. And to do this, it is one of the important aspects for the university to have a quality development of quality human resource. Of course, they are doing that, and we have to orient the students much towards this important mandate of the university. Since it is located in the biodiversity hotspot, its main research should be on the integration without losing the biodiversity. Then outreaching activities to take technologies to the farmer's doorstep, it's one of the aspects it has to fulfill in a great manner. Then only we can bring in a lot of changes in the agri sector. Today, we are talking much about the quality human resource development in any of the agricultural institutions or any other institutions for that matter of fact. We can see the development in case of space technology, how the father of space technology, Vikram Sarabhai, has led the team, and we are one of the foremost countries in the world to say. So it is very proud moment for us, and we are taking advantage of space technology in many of our agricultural activities, and even we are going to the resolution is increasing day by day, and we are able to catch even the farmer holding size and survey number and all those things. That is a very important thing. Of course, this university has been accredited in 2016 and 17. Of course, again, you may have to revisit the accreditation. That's very much needed. Otherwise, the recognition from the council like Indian Council of Agriculture Research is at stake. So for that, you may have to improve your the staff quality and staff training time and all those things. And they have to participate in this kind of lectures. That is very, very important for the staff and the students to expose them to the advanced technologies, what Dr. Arun Kumar sir has said today. That is one of the important aspects. It's actually very painstaking for me. I see very less participation from either from staff or from the students. Right. That is one more thing. Second thing is, although 2,455 students have been graduated from this university, about 141 gold medals have given, and most of them have been absorbed in many of the prestigious institutions and ARS activities. Of course, it is very, very encouraging, and I wish that many more things to be there in this kind of achievements for your university. Then coming to your research side, of course, you have 3 important crops. One is the rice-based farming systems. Second is the areca based and the cashew based. Of course, there are so many lot of startups are coming in these areas, particularly for crops like commercial crops like areca, cashew, and you can include introduce so many other crops into the Malnad area, which can support such kind of activities, because where water is not a limitation compared to the dry districts like Chitradurga and Davangere. That's very important aspect. And most of this crop diversification you have to bring in. You have to bring in crop diversification, and crop diversification based farming system is also very, very important for the university like Shivamogga. Then, of course, mechanization of small farm holdings. It is a major hindrance in many of the Malnad areas to give up the agricultural activity, and many of the farmers, particularly in North Canara and other places, they have left their farming and they have reached the urban centers. That is not correct. We should go back to the agriculture center and we should build our Atmanirbhar Bharata, but it helps in the, when you develop small mechanization, which helps in bringing down the drudgery. That's how we can encourage the youth to go back to the agriculture and to settle in agriculture, and they can come out with a new Bharat, Naya Bharat, with a lot of opportunities and making use of many schemes which have been doled out in the central sector schemes, particularly very near, in the period of COVID. They have come out with a Atmanirbhar Bharat. A lot of avenues have been created in this for youth to start their own enterprises and come out with the startups. Then the third one is the doubling of farmers' income. Of course, we are at it, and it's, of course, it is not only a dream, it's going to be realized very shortly because of so many the reforms which are being brought in. Particularly yesterday itself, our great parliament setup has passed out 3 important reforms which are related to agriculture and which are going to liberalize the farmers from the clutches of the commission agents and other things. And of course, it's going to give them much more push for Atmanirbhar Bharat. That is another thing. Of course, once again, it was a great learning from Dr. S. Arunkumar sir. Of course, I thank you very much for joining this great foundation on my behalf, being a member of Board of Management. I also thank you profusely, and I thank our Honorable Vice Chancellor and my good friend, Dr. Nayak, to give me an opportunity to address this Foundation Day celebration. Thank you once again. Thank you, one and all.
Of our chief guest. Participants have logged in around 250 locations, and in each location there may be 50 participants who are all viewing this program through YouTube. This is for your information, sir. So, sir, thank you very much once again. We know that you are packed with tight schedule at the headquarters. Nevertheless, you made your way through this online program, and it is of great strength to us. Thank you very much once again. Now, may I have the honor to invite Honorable Vice Chancellor of University of Agricultural and Horticultural Sciences, Shivamogga, and President of today's program, Dr. M.K. Nayak, sir, to offer presidential remarks.
So, very good afternoon to all of you. A wonderful day. At the outset, today's chief guest and the one who delivered the Foundation Day lecture, Professor Kiran Kumar, I would like to congratulate and compliment him for enlightening this particular audience of UAHS Shivamogga. In fact, there are about 250 locations, in each location not less than 50 to 100. Probably the number of viewers are not less than 1500. So that is a correction to Dr. Bhaskar. Please note it. So all are viewing in YouTube also. So at the outset, I would like to greet all those responsible for today's Foundation Day. Particularly, we have, traveled 7 years of journey and celebrating the 8th Foundation Day. So it's an opportunity for all of us to look back and see how we have traveled, and then also look forward as to how we should make correction in our journey. So I'm grateful that today we have Dr. Padma Shri, Dr. Kiran Kumar, and all our board members, esteemed board members, Ramesh Hegde, Chandrappa, Krishnamurthy, Arun Kumar, Shivaram, Bhaskar, Kushalappa, as well as our secretaries from Agriculture, Dr. Rajkumar Khatri, Dr. Prasad, Additional Chief Secretary, and Dr. Rajendra Kumar Kataria, Principal Secretary of Horticulture. Along with that, all my esteemed, it is a time to greet my officers, the former Vice Chancellors, Dr. Vasudevappa, Dr. Salimat, and former board members, the present board members, the officers of the present and the past, the registrars, the dean, the director, and all my faculty members whom I always consider as the soul of the institution, soul of the university, who are the intellectual backbone of the society, and then all our employees. ನನ್ನ ಎಲ್ಲ ನೌಕರ ಬಾಂಧವರು ಮತ್ತು ಕಾರ್ಮಿಕ ಬಂಧುಗಳು, ಇವತ್ತು ಅವರು ಬೆವರಿದೆ ಈ ಯೂನಿವರ್ಸಿಟಿ. ಈ ಒಂದು whatever you say today, the university has started leaving its footprints on the soils of Malnad region. ಈ ಮಲೆನಾಡಿನ ಮಣ್ಣಿನ ಮೇಲೆ ಏನು ತನ್ನ ಪ್ರಿಂಟ್ ಅನ್ನ ಬಿಡ್ತಾ ಇದೆ, ಹೆಜ್ಜೆ ಗುರುತುಗಳನ್ನು ಹಾಕ್ತಾ ಇದೆ. ಆ ಹೆಜ್ಜೆಗೂ ಕೂಡ ಎಲ್ಲ ಸರ್ವ ವಿಶ್ವವಿದ್ಯಾಲಯಕ್ಕೆ ಸಂಬಂಧಪಟ್ಟ ಎಲ್ಲರೂ, ಸರ್ಕಾರದಿಂದ ಹಿಡಿದು ಕೊನೆಯ ಬೆವರು ಸುರಿಸುವ ಕಾರ್ಮಿಕ ಬಂಧುಗೂ ಕೂಡ ಇದಕ್ಕೆ ರೆಸ್ಪಾನ್ಸಿಬಲ್, ಗುರುತರವಾದಂತಹ ಜವಾಬ್ದಾರಿಯನ್ನು ಹೊತ್ತಿರೋದ್ರಿಂದ ಇವತ್ತು ವಿಶ್ವವಿದ್ಯಾಲಯ ಒಂದು ಸುಗಮವಾದಂತಹ ಪಯಣವನ್ನ ಮಾಡ್ತಾ ಇದೆ. ಎಲ್ರಿಗೂ ನಾನು ಶುಭಾಶಯಗಳನ್ನ ಅರ್ಪಿಸ್ತೇನೆ. Then university, of course, has been located in a wonderful place under the folds of Western Ghats, and definitely very challenging. There is a natural bounty, nature's bounty is with us. It's challenging also. We have 7 districts, and the rainfall ranges from 300 millimeter to 4,000 millimeter. I think Professor Kiran Kumar may understand the amount of challenge that the university has got to tailor the technologies for 300 millimeter to 4,000 millimeter. So that is the challenge that we have. Definitely, we have diversification of crops. In fact, the crops of this region are, high valued crops like arecanut, coconut, cashew nut, very commercial crops. In fact, if you look at Karnataka state in the last 10 years, the cropping pattern has changed. It has changed. Almost 12.5 lakh hectares have been substituted by high value crops, including areca around 51%, and banana around 81%. And then you have coconut around 13%, onion, and then so many crops have substituted the food secured crops, which were earlier, we were calling them as food secured crops, cereal crops, pulses. ಹೊಟ್ಟೆಪಾಡಿಗೆ ಕೊಡುವಂತ ಬೆಳೆಯನ್ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದೆ ಹೈ ವ್ಯಾಲ್ಯೂ ಕ್ರಾಪ್ಸ್. ಹಾಗಾಗಿ there is also a major challenge. We should consider that fact. And similarly, we have about so much of area in the 7 districts with so many crops: agriculture, horticulture, fisheries, dairy industry, and our Krishi Vijnana Kendra has to look after all these entrepreneurship, and that is why it's quite challenging. Absolutely, no doubt, we have been trying to live up to the expectations of the farmers. More importantly, I would like to recall the the people who have toiled hard in establishing this university. All those, the government of Karnataka is quite generous in providing the fund in the first phase. We are going to have our headquarters located at Iruvaki, which is 50 kilometers away from Shivamogga town. So, which is also very much in the folds of Western Ghats. And today's, Foundation Day lecture presented by the Doyen of Indian Space Research, one of the Doyens of Indian Space Research, Dr. Kiran Kumar. I think, as we know, he mentioned the very first slide, the name of Professor Sarbai, Vikram Sarbai, the father of Indian space research, and the very name is inspiring. And today I'm very happy that Kiran Kumar is the professor of Sarbai. So he's in the name of Sarbai, is the Professor Sarbai at Indian Space Research Organization. So the very name is inspiring because Indian space research has reached its pinnacle. Rather, we started late in, almost in 60s. It was a solid foundation laid by Professor Sarbai. Then, today we in India, we are we belong to the elite groups of the countries like France or other Russia, like that. That means we have a say, and we can proudly say we belong to the elite groups in space research, obviously because of the solid foundation laid by Professor Sarbai, followed by the other doyens like Satish Dhawan, and then Professor U.R. Rao, and then Kiran Kumar, and even the latest one, Shivan. So all these doyens have contributed extensively, and we are happy to have one of the doyens today who gave rather a ton of knowledge for agricultural universities. There are many agricultural university vice chancellors watching this all over India. Many scientists are watching. I'm sure you have given so much of knowledge and enlightened where the Indian agriculture has to proceed using the technological input of ISRO. Certainly, we'll make use of that one. And coming to his, of course, we are quite happy to listen to him because his contribution, particularly as having designed and developed more than 50 electro-optical fibers, it's a very monumental contribution and is very significant in terms of the success of Chandrayaan-1 and also Mangalayana, Mars orbit. And being a Vikram Sarbai professor, he is now going for many schools. I was told that itself is a great education. And I feel at this moment, a proud son of Karnataka, rather I would call in Kannada, Kannadambeya, ಒಬ್ಬ ಹೆಮ್ಮೆಯ ಪುತ್ರರೊಬ್ಬರು ಇವತ್ತು ಈ ಒಂದು ಸ್ಥಾನದಲ್ಲಿ ಕುಳಿತು ನಮಗೆ ನೀಡಿರುವ ಸಂದೇಶ, ತಾವು ನೀಡಿರುವ ಏನು ಜ್ಞಾನ, ಆ ಜ್ಞಾನವನ್ನ ನಾವು ಆಕ್ಷನ್ಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಿ, ಕರ್ಮವನ್ನ ಮಾಡಿ, ಅದರಿಂದ ವೆಲ್ತ್ ಅನ್ನ, ಸಂಪತ್ತನ್ನ ಹೇಗೆ ಗಳಿಸಬೇಕು ಅನ್ನೋದ್ರ ಕುರಿತು ಯೋಚನೆಯನ್ನ ಮಾಡ್ತೇವೆ ಅಂತ ಹೇಳಲಿಕ್ಕೆ ಇಷ್ಟಪಡ್ತೇನೆ. ವೆರಿ accomplished, and we acknowledge and hats off to you for your monumental contribution, sir. And you have accepted our invitation, and having accepted our invitation in spite of a busy schedule, you have really made an eventful day in the history of UAHS Shivamogga. Thank you very much, sir. Now coming to the Indian agriculture as a presidential remarks, I think we have traveled a long distance of 70 years. 70 years of Indian agriculture after the post-independence period. Probably we will be celebrating in another 2 years, 75 years of Indian agriculture, where our Honorable Prime Minister is aiming for doubling the farmers' income. Not only the Prime Minister, every one of us are after the doubling of the farmers' income. Definitely, in these 70 years, there has been a revolutionary changes in agriculture. I would rather call change has been visible, that we were food deficient countries, and today we are food sufficient countries, and we were importing countries. Today we are exporting country, and we were a food insecure nation, and today we are a secure nation as far as food is concerned. And to kindly to bring it to the notice of Professor Kiran Kumar sir, during the COVID era, you mentioned, during the COVID era from March to July, the country did not witness the starvation and that entire credit, because for all those sections of the people, irrespective of the below poverty line, above poverty line, laborers, every force was fed almost about 24 million tons. And still our Godan has got 81 million tons. And even before the Rabi wheat crop were put into Godan, that means plus another 100 million tons. That means we are so comfortable, 180 million tons probably. I don't know the exact figure, but nearly more than 150 to 180 million tons. That shows the strength of these agricultural farmers, the political will, and the scientific skill which has contributed. These are the ingredients which has contributed. That is why, and in fact, I would also, it's a matter of privilege to say that this is the only country in the world to have the enacted Food Security Act. No other country. That is where we have promised in the highest form of parliament that we will be able to feed the 60 crore people through the public distribution system. That is our strength, and all that goes to the farmers, our Kisan, the scientific research, and the policies which has favored. Now, with this 65% of the country's employment depends upon agriculture, almost 14% GDP contribution, and we are contributing almost 20% to the export. With all these 600 million farmers, we have much more challenges. The challenges are of higher order, because one is, as I told you, today our food basket or annual production is 295 million tons. And that is actually one of the problem of plenty. Production problem. Production is plenty problem. Problem is, plenty of production. At the same time, we need to channelize where it should. That's why I would call, I think one of the suggestions, the advice Professor Kiran Kumar gave was forecasting of food crops well in advance before the season. That means forecasting of major food crops in advance. That is very important, because if we can forecast, because now the challenge is, it is a problem of plenty. That is one challenge. Second challenge is depletion of natural resources, whether it's a water, land, fertility, and land degradation. Then including the reduction in the land size, per capita land. It's 1970 it was 2 hectares. 2000 it came to 1.5 hectare. Today it is less than 0.75 hectare. That means we have to tailor the technology to the land of our size. And of course, there is a climate change is another very big challenge, and shortage of labor. These are all the things. There is also volatility on prices. Yesterday, the parliament has passed the bills concerning these, and also some emergency problems like that of COVID. That's what we are experiencing today. So all these will add, and probably when we say all these are our challenges, and to meet these challenges, we need certain out-of-box technologies. And what Professor Kiran Kumar highlighted today is the convergence of technology. The convergence in terms of space technology, convergence in terms of biotechnology, convergence in terms of information technology, climate technology, all these convergence are needed. And I was very glad to listen to Professor Kiran Kumar, because they have got variety of remote sensing satellites, which can always give synoptic observations, not only synoptic observations, which can give the information of mapping of large land and matching of large ocean. That's very important. One of the Atmanirbhar program is to Honorable Prime Minister and the Government of India has provided 20,000 crore for sea farming. That means that what Professor Kiran Kumar mentioned, apart from the aquaculture, inland, the ocean culture, where the sea farming, where the timing and even through navigation, giving a warning where to go, how to fish, and where exactly they can get the bountiful fishes. All these information is definitely connected to that particular synoptic observation, as well as repeat coverage of large area of sea and land. That will definitely help. And the second point that I just mentioned was forecasting of the yield of the major crops, because that will help us for crucial decision. Because today if you have about 295 million tons, it's a problem of plenty. That we need well in advance as to how much has to go for export, how much has to go for processing, value addition, storage, public distribution system. If all these are available to us well in advance, probably we can definitely see that nothing is wasted. For example, place like Shivamogga, where pineapple is one of the best crops. 95,000 tons were produced during the COVID, but we could not deliver it mainly because of the lockdown. That's why perishable commodities are there, agricultural food commodities are there, for which we require a forecasting, which is possible. I think that can help us in taking a crucial decision. Similarly, even to move for movement of agricultural produce also, that is a wonderful idea. Then there is important program Professor Kiran Kumar mentioned is FUZZLE, where it is to forecasting of agricultural output using space and agro-meteorology and land-based information. That means combination. That's why I told blending of remote sensing, meteorology, and econometrics, which has helped for this particular FUZZLE system, which we have been using for insurance also. Then the most important point that I want to mention is dry land productivity. Karnataka today is the second biggest state after Rajasthan. And in the last 15 years, we have got almost about 11 droughts. That means 11 years of drought. That means we need definitely to address the rain-fed agriculture, dryland agriculture, for which we definitely need the integrated development using the space inputs. And similarly, not only rain-fed agriculture, even command area. Look at the command area. We have, Krishna belt, we have a Kaveri belt. In Karnataka, we have a Tunga belt. Look at these belts. Definitely, the water use efficiency at the national level is worked out to be around 29%. Let us remember, if by any means of these applications of space and others, if it could be increased by another 10%, we will have another 50 million tons. Another 50 million, solid 50 million tons, which could boost our export. Probably right now our export is $38 billion. And if it could be doubled, probably we will be in a position, commanding position. So that is the another area. Similarly, enhancing the irrigation efficiency and restoring the irrigation potential of the major reservoirs. And I think for which we require the temporal satellite data, because our reservoirs right now, even if you want to restore them to their original capacity, definitely a lot of scope is there. And then another important is in the irrigator belt, what we see is salinity of the soil, alkalinity, and reclamation of the land. This is what Professor Kiran Kumar mentioned. That is also another important area. Then, most important thing that he mentioned was web-based information system. Two important programs. One is Bhuvan, which Karnataka government has used it. Similarly, Bhu Sampada, which are the direct effects of ISRO's contribution. And most importantly, lastly, he also mentioned the forecasting, weather forecasting. Today in Shivamogga, we are facing a depression. Bay of Bengal, there is a depression. And the entire Malnad region and transitional belt is red alerted. So we are going to have it for another 3 days. And I would like to point out here, Professor Kiran Kumar, last year in Shivamogga region, we faced drought up to July 26th. And suddenly from July 26th before August 10th, every raindrop was downpoured in Shivamogga. Not only in Shivamogga, and the entire belt of 6 lakh hectares submerged. 6 lakh hectares, 7 lakh people affected. Thanks to your technology, because you could save the lives of the people, but we could not save the lives of the crop. And that is what we wanted the next step, whether we can save the lives of the crop, because I think where the forecasting, prediction of the weather changes, including your, that is a very complex process, as I heard, is a complex dynamics, interactions of ocean, as you mentioned, ocean atmosphere, several years of ocean atmosphere, even low pressure, depression, all these things have to be quantified, which really takes a lot of input. But definitely using our automatic weather station or GPS system today, I am proud to say that Forestry College at Panchayat has got land, the GPS system, well-established laboratories, and we have been making use of to some extent. I think using GPS and Doppler weather radar, it should be possible for us to have a good prediction what Americans and France today, even if they want to go out, they will just click at the internet and see whether it is raining or cloudy and then proceed. That much of accuracy and information. It's after all age of information. And definitely those things could definitely contribute for our prediction of weather and rain. And even another most important point is global warming. Global warming, you mentioned, if there is a, because of the greenhouse gases, if there is a heavy precipitation, that is another thing that we noticed. 2019, almost it was estimated at 35,000 crore worth of rupees crore worth of the asset was lost. And similarly this year, even with the small flood, we have, it is estimated at 8,800 crore. And particularly we being located in Malnad region or areas like Coorg region, last year we faced a landslide rainfall, and if rainfall was excess, it was a landslide, and probably we can definitely take up a study as to the reasons for such a landslide, because a lot of development is going on, afforestation, even establishment of resorts in those areas. These are all the studies that I think we can really take up. Coorg region, and then I think precision agriculture that you mentioned, using, because after all, Indian agriculture, 600 million farmers, of which 85% are smallholders, less than 1 hectare. And it is going to, whether we like it or not, we are going to stay with them, small farmers. And it's going to be a paradise of small farmers in future agriculture. Keeping that one in view, I think Internet of Things, IoT, what our Krishi Vigyan Kendra is also aiming for, IoT, where the real data can be harvested, and those data, real-time data, can be analyzed for smart agriculture. That is another aspect. And use of drones, particularly, I am interested to see, because we are, we have about 4 lakh acres of areca, and areca is a lifeline of our farmers here. And in order to spray for areca, half a dozen times you have to climb the areca tree, I think, for which drones, monitoring, using drones and crop monitoring, it should be possible to not only spray, because it is estimated that these drones can spray 5 times faster than the existing sprays. And that is going to be a boon for us. And then probably using these 3D image, the drones can help us in frequently identifying the flood and droughts. So these are some of the important things that we expect in future. And another important, the last point probably, is change in the cropping pattern. Drones can also help us in identifying what change has happened every time in the cropping pattern. Tomorrow, if you want to fix up the price, MSP, minimum support price, then we can always advise the farmer that if you can plant here, you won't get the MSP. If you plant there, you get the MSP. Such things are possible by drone monitoring, and by saying what are the cropping patterns, what changes have taken place. In fact, Karnataka, in addition to 12.5 lakh hectares, have been diverted from low value crops or food secured crops to high value crops. In addition, 21 lakh hectares of area is what we call it as Padbhumi, not being under cultivation. So there's a big challenge for agricultural scientists, technocrats, using the convergence, all the input from the various technology like space technology, like biotechnology, by climate technology, it should be possible to bring back the glory of all those 23 lakh hectares. With this, I think I once again congratulate and compliment Professor Kiran Kumar for his very enlightening address. And you have given us, I think we would have been happy to have you physically present here. I'm sure we will have one day to call you and invite you. And in advance, I'm intending that you please accept our invitation to be here in Shivamogga to go around our new campus, and we'll make the best use of your advice. And I once again recall the services of our for predecessors, former vice chancellors, and then the former governing board members, the present governing board members, the present deans, the registrars, the directors, also the previous, and my young faculty as well as elder faculty, whom I always consider the intellectual backbone of the society. Those are the inspiration for the younger generation. They have risen to the occasion of COVID and offered as many as 1,200 online lectures all of a sudden. That's what I would appreciate. Hats off to ISRO technology. These are all information technology which has come from ISRO today. And I would also like to highlight our KVK scientists have risen to the occasion. Almost about 978 tons of vegetables and fruits were marketed through social media, and that was a worth of 4.5 crores rupees. And that's also, suddenly our scientists rose to the occasion. And I'm sure in future days, with all these challenges, having been located in vulnerable position, they will rise to the occasion irrespective of COVID or other things, because we are here, human beings after all, here to beat the problems, not to be beaten by the problems. I'm sure all these problems will be taken care by our faculty, our alumni, our students. Alumni, in fact, they are our ambassadors. I'm sure some of them are listening. I take this opportunity for giving me an opportunity to speak a few presidential remarks, and all that is possible because of everybody's contribution. Thank you very much once again. Let us give a standing ovation to Professor Kiran Kumar. Please stand up for a minute to give him a standing ovation, please. Thank you very much, sir. Thank you on behalf of the university, also on my personal behalf. Thank you very much.
Thank you very much, sir, for your valuable, conclusive, and thought-provoking presidential address. Always, you have been a source of inspiration and strength to all of us in the pursuit of excellence in teaching, research, and extension activities of the university. Further, under your able guidance and leadership, our young university will fly to greater heights in the days to come. So, with these few remarks, finally, now I request the respected Director of Extension of the University, Dr. Shashidhar sir, to please propose vote of thanks for one and all who have graced this occasion and also caused for success of this Foundation Day program.
Namaste. ವಿಕ್ರಮ್ ಸಾರಾಭಾಯಿ ಅವರ ಕನಸಿನಿಂದ ಪ್ರಾರಂಭಿಸಿ ಅವಕಾಶಗಳ ಆಗರವನ್ನು ತೆರೆದಿಟ್ಟು ಅವುಗಳನ್ನ ರೈತರ ಬಳಕೆಗೆ ಪ್ರೋತ್ಸಾಹಿಸುವ ಕುರಿತು ನಮ್ಮ ಪದ್ಮಶ್ರೀ ಕಿರಣ್ ಕುಮಾರ್ ಅವರು ನಮ್ಮೊಂದಿಗೆ ಹಲವಾರು ವಿಷಯಗಳನ್ನ ಇವತ್ತು ಹಂಚಿಕೊಂಡಿದ್ದಾರೆ. ಮೊಟ್ಟ ಮೊದಲನೇದಾಗಿ ನಾವು ಈ ಒಂದು ತಂತ್ರಜ್ಞಾನವನ್ನು ಬಳಕೆಗೆ ಪ್ರಾರಂಭ ಮಾಡಿದಾಗ ಗ್ರೌಂಡ್ ಟ್ರೂತ್ ಅನ್ನ ಮಾಡಬೇಕು ಅಂತಂದ್ರೆ, ಅಂದ್ರೆ ಮಾಹಿತಿಯನ್ನು ಸಂಗ್ರಹಿಸಬೇಕು ಅಂತಂದ್ರೆ ನಾವೆಲ್ಲ ಆ ಜಾಗಕ್ಕೆ ತಲುಪಿ ಸಂಗ್ರಹಿಸಬೇಕಾಗಿತ್ತು. ಈಗ ನಮ್ಮ ಕಿರಣ್ ಕುಮಾರ್ ಅವರು ಹೇಳಿದ ಹಾಗೆ ರೈತರೇ ಈ ಮಾಹಿತಿಯನ್ನು ನೇರವಾಗಿ ನಮಗೆ ಕೊಡ್ತಿದ್ದಾರೆ, ಎಲ್ಲಿ ಯಾವ ಬೆಳೆ ಯಾವ ಲೊಕೇಶನ್ ನಲ್ಲಿ ಬೆಳೆಸಿದ್ದಾರೆ ಅಂತ. ಅಂತಹ ಒಂದು ಮಾಹಿತಿಯ ಆಗರವನ್ನ ನಮ್ಮ ಮುಂದೆ ತೆರೆದಿಟ್ಟು ಇವತ್ತು ನಮ್ಮ ಜೊತೆಗಿದ್ದು ಈ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಒಂದು ಶೋಭೆಯನ್ನು ತಂದುಕೊಟ್ಟಿದ್ದಾರೆ. ಅವರಿಗೆ ಎಲ್ಲರ ಪರವಾಗಿ ತುಂಬು ಹೃದಯದ ಧನ್ಯವಾದಗಳನ್ನ. We are very proud to have Dr. Kiran Kumar with us for this great occasion. I thank profusely Dr. Kiran Kumar for gracing this particular occasion and making us proud. Thank you, sir. Thank you. I thank our team leader, Dr. M.K. Naik, for being a guiding force for all of us and organizing this wonderful event successfully. Thank you, sir. ನಮ್ಮ ನಾಯಕರಾದ ಎಂ.ಕೆ. ನಾಯಕ್ ಅವರಿಗೆ ನಾನು ಧನ್ಯವಾದಗಳನ್ನು ಹೇಳಲಿಕ್ಕೆ ಇಷ್ಟಪಡ್ತೇನೆ. ಇಡೀ ಯುವ ಸಮೂಹ ಮತ್ತು ವಿಶ್ವವಿದ್ಯಾಲಯದ ಸಮೂಹವನ್ನ ಒಟ್ಟಿಗೆ ತೆಗೆದುಕೊಂಡು ಹೋಗಿ ಈ ವಿಶ್ವವಿದ್ಯಾಲಯದ ಏಳಿಗೆಯಲ್ಲಿ ಪ್ರಗತಿಯಲ್ಲಿ ಉನ್ನತ ಪಾತ್ರವನ್ನು ವಹಿಸುತ್ತಿದ್ದಾರೆ. ಇವತ್ತು ಅವರು ನಮ್ಮೊಂದಿಗೆ ಈ ಸಭೆಯ ನೇತೃತ್ವವನ್ನು ವಹಿಸಿ ಕಾರ್ಯಕ್ರಮವನ್ನು ನಡೆಸಿಕೊಟ್ಟಿರ್ತಾರೆ. ಅವರಿಗೆ ಧನ್ಯವಾದಗಳು. ಈ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ನಮ್ಮ ಆಡಳಿತ ಮಂಡಳಿಯ ಎಲ್ಲ ಸದಸ್ಯರು ಭಾಗವಹಿಸಿದ್ದಾರೆ. ರಮೇಶ್ ಹೆಗಡೆ ಅವರು, ಚಂದ್ರಪ್ಪ ಅವರು, ಕಿರಣ್ ಕೃಷ್ಣಮೂರ್ತಿ ಅವರು, ಅರುಣ್ ಕುಮಾರ್ ಅವರು, ಶಿವರಾಮ್ ಹಾಗೂ ಭಾಸ್ಕರ್ ಮತ್ತೆ ನಮ್ಮ ನೆಚ್ಚಿನ ಫಾರೆಸ್ಟ್ರಿ ಡೀನ್ ಆದಂತಹ ಕುಶಾಲಪ್ಪ ಅವರು ಸಹ ಈ ಕಾರ್ಯಕ್ರಮದಲ್ಲಿ ಭಾಗವಹಿಸಿದ್ದಾರೆ. ಹಾಗೆಯೇ ನಮ್ಮ ಕಾರ್ಯದರ್ಶಿಗಳು ಈ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಭಾಗವಹಿಸಿದ್ದಾರೆ. ಅವರೆಲ್ಲರಿಗೂ ನಮ್ಮ ಈ ಟೀಮ್ ಕೃಷಿ ಮತ್ತು ತೋಟಗಾರಿಕೆ ವಿಶ್ವವಿದ್ಯಾಲಯದ ಪರವಾಗಿ ತುಂಬು ಹೃದಯದ ಧನ್ಯವಾದಗಳನ್ನ ಅರ್ಪಿಸುತ್ತೇನೆ. I thank all our esteemed board of management members from our side. Thank you, sir. And I also thank all the online and offline participants across the country, including our alumni, students, and vice chancellors, ex-vice chancellor, board of management members, and all are participating across the country. So I thank one and all for gracing this occasion. Thank you, sir. I'm very proud to say around 250 logins are there in our YouTube channel, and along with that, we are having around 20 centers in our university wherein we have connected more than 50 participants each of these places by following all the social distancing and COVID care phenomena. And it's a great occasion to have this type of gathering and making this event as a grand success. I thank one and all involved in organizing this particular event. Thank you once again. Thank you, sir. And I thank all our media partners taking over this particular journey through online to the entire social media and also our print media and also television media. I thank all our media partners and farmer friends. Thank you one and all.
I also thank Dr. Shishidhar, Director of Extension, University of Agricultural Sciences, Shivamogga, for having thanked all the
ಸರ್ ಇಲ್ಲೇ ಸ್ನಾಕ್ಸ್ ಇಲ್ಲೇ ಸರ್ವ್ ಮಾಡ್ತಾರೆ.